Welcome back, cyberscripters. In this session, we will talk about a frequently asked interview question, that is difference between shallow copy and deep copy. So let's see what it is. So before dwelling into the topic, let's just understand how does this help interviewer, or when an interviewer asks you this question, what actually he is looking for. So when an interviewer asks you this question, he wants to understand your understanding of how copying objects work in Python, especially for mutable and nested data structures. We'll see in this session how a normal data structure versus nested data structure differs when we are copying it. Another thing is he it helps him to understand your awareness of potential issues related to object mutability and reference sharing. So basically, he wants to understand how good is your understanding of data structure and references. This is really important because when you work with nested data structures, it is very important that you understand the references, how they are copied, and how they can impact the performance and functionality of your program. So first, let's see what it is. So let's say we'll take an example of a list. So let's say I create a list. LST1 is equal to some numbers. Now what happens is this list is created in memory and we have a variable that is pointing to this list. Now when I say ls2 is equal to ls1 or ls3 equal to ls1 or any variable is equal to lst1, we are not copying that list. Actually what we are doing is we are creating two more reference variable which are pointing to the same list. So if I give you an analogy, it is calling the same person with different names. Let's say you have person X and you call him by name A, B, C, you will get the same person. So we are just copying different names to the same object. That is the only thing we are doing here. We are not copying the list. So now let's look at copying of list. So first we look at shallow copy. Now let's take an same example. Let's say I have a list. And when I do lst2 is equal to lst1 copy, I'm actually creating a new copy. Now lst2 is not pointing to this list. There's a separate copy and ls2t is pointing to that list. Now if I change lst2 and I say lst2 zeroth index is equal to 100, we are changing ls2 list. But this list which is pointed by lst1, that is not changed. So if you have a normal list without any nested structures, this copy would work fine and you would have two different copies. But if you have a list or a data structure which has nested structures inside it, let's say you have a list wherein you have a list inside list or a dictionary inside list, then things would change. Let's see, I have a list lst1. Inside I have another list 1, 2, 3, 4. There's another list 5, 6, 7, 8. Then there's a dictionary. Then there's a variable that is again a list. And then two integers. Now how is this stored? So in my main list, only the references are stored or the address of the memory location is stored for the nested objects. And these are called references. So see reference 1 is pointing to 1, 2, 3, 4. Reference 2 is pointing to 5, 6, 7, 8. Reference 3 is pointing is to this dictionary. This temp list is pointing to another list. Now these integers, they are normal integers and they are stored as is. Now let's see what happens when we do copy. Now I am executing now I am executing ls2 is equal to ls1 dot copy. Now what happens is basically a new list is created. This list is created, but this nested list they are not copied, and these references are still pointing to this original list. So what is the problem here? The problem is if I say ls24 is equal to 600, well, this is a normal integer. If I change that, it would be changed in ls2 but not in ls1. So things are fine here. But as soon as I change this ls2 1, so this is my ls2 1 or lst1, so this is 1 and this is 0 element in that. Now if I changing it from file to abc, it is getting changed for both the lists. So this is a problem with shallow copy, that the references are copied but the objects are not. So a shallow copy creates a new object but does not create new object for elements contained within the copied object. So this is a basic definition of shallow copy. So it definitely creates a new object, but new object for elements. So these are the elements which are contained within this main list. They are not copied. Now let's look at deep copy. Now let's understand deep copy. So what is happening here? Let's take the example of same list. Now when I say lst2 is equal to copied or deep copy, not only the original list but all the reference objects are copied. Now if I do ls2 1.0 equal to abc, it is changed only here, not here. So your deep copy would copy your original object and all the reference objects. So the definition would be a deep copy creates a completely independent copy of the original object and all the objects contained within it. This is very important. So this is general understanding of deep copy and shallow copy. Now let's write a small program and let's see how things work. So now let's go ahead and execute our code in Python Tutor and let's visualize what's happening. So this is our code. We'll execute it line by line. We'll get output here and we'll get visualization of our objects here. So let's start. So here we are creating a list lst1. As you can see, this variable is referring to this list. Now let's do ls2 is equal to lst1. Now when we execute this code, we have another variable that is pointing to this list. So actually we are not copying the list. We are just copying the references. Now let's just print list1 and list2. And as you can see, we are getting the same list 1, 2, 3, 4. Now let's change lst2 first index to 100. So this will be changed to 100. Now when we change it for ls2, it changes for ls1 as well. Let's just print it out. So as you can see, copying references is not actually copying lists. Now let's go ahead and look at our shallow copy. So this is our shallow copy code. Let's just go ahead and execute this as well. So here we are creating a list ls2 lst4. It has two integers 1 and 2, one nested list with elements 3 and 4, then again an integer and a nested list. So let's see how does that list actually look like in memory. So in memory lst4 is referencing to this main list and the second index is pointing to this nested list and index 4 is again pointing to this nested list. Now let's do our copy, our shallow copy. Now what is happening in shallow copy is we are creating a new list, but the references the reference objects are not copied. So index 2 of LST4 and index 2 of LST5, they both are pointing to same object. Now let's just go ahead and change LST4 index 1 to new text. So LST4 index 1 is this. Let's just go ahead and change it. So when we change this, only this is changing. LST5 still has 2. Let's just go ahead and print it. So as you can see, list 4 has new text while list 5 still shows number 2. Now let's just go ahead and change LST4 index 4 index 1. So this is my index. So this is my index 4 and it is pointing to the list. So when I take first index, we are actually changing this thing. So my LST441 is here. Now let's just go ahead and change it to triple one. Let's see what happens. See, it has changed triple one. But now LST5 is also pointing to that. So for both this LST4 and LST5, for both lists, this value is changed. Let's see. So here you can see triple one. In list 5 also you can see triple one. So in shallow copy, the references are copied, a new list is copied, and all the references and numbers are copied, but the reference object, the nested objects, they are not copied. Now let's look at deep copy. So this is our deep copy code, right? So what we are doing is we are creating a list and it has nested list with a dictionary and a variable which is pointing again to a list. So let's just visualize the now let's just create our list first. So this is our list is created. My list one is pointing to this list and it has three references. First is pointing to a nested list, next is pointing to a dictionary, and third is again pointing to a list. Now let's do our deep copy. Now, as soon as I do a deep copy, see what is happening is this list is copied and all the nested objects they are also copied as separate objects. So now if I do list index 0 index 2 is equal to 100, we would be changing list 1 index 0 and then index 2. So this is my index 2 number 3. So when we change list 1 index 0 index 2 is equal to 100, we would be replacing this 3 by 100 because this is my 0th index of list 1 and this is my second index. Now let's just go ahead and do that change. So as soon as I execute line number 6, this value is changed to 100. But if we look at list 2 is pointing to index. This is 0th index of list 2 and this is index 2 of that list. It is still showing 3. So let's just go ahead and print both the lists. So this is my first list and this is my list 2. And you can see the difference here. Here it is 100, here it is 3. So what does it mean is when we do a deep copy, all the reference and all the reference objects, all the nested objects are copied as well. So you basically get a complete independent copy of your object. While in shallow copy, only the main object is copied while the reference objects are not copied. So you need to take care of this when you are doing copy. And you have to make sure that if you have nested objects, you need to make sure that you do a deep copy and not a shallow copy. Otherwise, it will result in inconsistent data. Thanks for watching. Like and subscribe if you are interested in this kind of content. Thank you.